We are on the textbook homework for Algebra 3-2, Chapter 3, Lesson 2. We're on page 136. Starting with number 1. So we're going to determine if the value of x is a solution for the equation. So we are testing the value of x to see if it works. So we have the equation 11 minus 9x equals 47. We want to know, is x equals 4 solution for the equation? So we're going to go ahead and replace x with 4 and test it out. So 11 minus 9, and now instead of x times 4, that's multiplication, equals 47. We're going to go ahead and run those numbers. So 9 times 4 is 36. So this is 11 minus 36 equals 47. You can see if this was plus, we'd end up with 47. But 11 minus 36 is going to be negative 25. So negative 25, does that equal 47? No. So the answer here for letter A is no. X equals 4 is not a solution. Letter B. 3x squared plus 4x equals 55. We want to know, does that work for x equals negative 5? So everywhere we see an x, we're going to replace it with negative 5, and then we have to follow our order of operations. So it's 3 times negative 5 squared plus 4 times negative 5. Does it equal 55? Notice how I put it in parentheses. The x is being squared, not the 3x. All of this would have to be in parentheses, the 3 and the x, if you were going to multiply those together and then square it. The squared is only on the x, so it's negative 5 being squared. Not just 5 either, negative 5. You got to be careful how you punch this in your calculator. A lot of people will just do negative 5 squared, and you get negative 25. But you got to be smarter than that. We know a negative times a negative is a positive. If you're going to put this in the calculator, you need parentheses to get a positive 25. Otherwise, the calculator is only squaring the 5 and leaving the negative out front. So we have to be smarter than the calculator and know this means negative 5 times negative 5. And a negative times a negative is a positive. So this becomes 25. So it's 3 times 25 plus 4 times negative 5. So this is 75 plus negative 20 equals 55. Does it equal 55? 75 minus 20, or adding negative 20, does get you 55. So both sides come out equal, meaning this is a solution. So the answer to the question here is yes. And then letter C. Negative x to the third, notice no parentheses here, so the negative is not part of this, equals 64 for x equals negative 4. So we have to be careful how we plug this in. So we're going to leave the negative out front. It's not in parentheses. It would have to be in parentheses if that was part of the cubed or raised to the third. So the x becomes negative 4. I'm going to put that in parentheses. That's being raised to the third. So this is a negative times a negative times a negative. This is negative 4 times negative 4 times negative 4, and this negative is just hanging out here in front. That's what this actually says. So a negative times a negative is a positive, times a negative is a negative. 3 negatives make a negative. So my answer here is going to be negative, and this negative out front is going to hang out there, which means in the end, those 2 negatives are actually going to create a positive. So we have to keep track of all that. So if you were going to plug this in your calculator, you have to use parentheses, negative 4. Raised to the third power, it's negative 64. So I get negative 64 because this negative follows all the way down, which makes it positive 64. And that means that this is a solution. It does work. Okay, question number 2. Oh, yep, number 2. So in questions 2 and 3, we're going to solve by making a table. And then we're going to circle the row on the table that has the solution. All right. So we're going to make a quick table for 2x plus 2. And we want to know, when does it equal 6? So I'm going to plug in numbers like 0 and 1 and 2 and 3 into the expression 2x plus 2. We're trying to figure out, when does it equal 6? For what x value does the expression 2x plus 2 equal 6? So you plug in 0, 2 times 0 is 0, plus 2 gives you 2. Plug in 1, 2 times 1 is 2, plus 2 is 4. Plug in 2, 2 times 2 is 4, plus 2 is 6. I'm going to stop right there and circle it. So this expression, 2x plus 2 equals 6 when x equals 2, when we plug 2 in for x. So this is the solution. It's when x equals 2 that we get a 6. And since we already have 3 here, 2 times 3 is 6 plus 2 is 8. And you can see the pattern of this expression is going up by 2. And again, that comes from here, not here. We need to be careful. Okay, because we're multiplying by 2 here, this is going to be an increase of 2 every single time. Okay, question number 3. The expression is negative 5a plus 7. We want to know when does it equal negative 23. So I'm going to put, well, it's not an x, so it's an a. And it's negative 5a plus 7. I'm going to start with 0. If I plug 0 in, anything times 0 is 0, plus 7, 7. So I need to figure out when does this equal negative 23. Right now I'm not anywhere close. So maybe I better up the ante a little bit. Let me plug into negative 5 times 2, that's negative 10. Negative 10 plus 7 is negative 3. I'm still not anywhere close here. So let me plug in a bigger number. How about 5? 5 times negative 5 is negative 25. Negative 25 plus 7 is negative 18. All right, now I'm getting close. And if you notice the coefficient, here is 5. That means this is going by 5s. If I was going by 1s here, this would be going by 5s. 18 and 23 are 5 apart. That means I'm only one number off. So even if you didn't see that, you should know that 18 is close. Let's try 6. Plug it in. Negative 5 times 6, that's negative 30, plus 7 is negative 23. And that right there, x or a equals 6. That's the value of the variable when this expression equals negative 23. Okay, moving on to number 5. We're going to solve by making a graph. I put one of these on here because these can be confusing. I'm going to make a 4-quadrant graph. Sometimes you don't have to make a 4-quadrant graph, but it always is good to start there sometimes just because you don't know where it's going. And I've got 5x minus 18. That's what I'm plotting, and I want to know when does y equal negative 3. So this is going to create some kind of line, and if I have negative 1, negative 2, negative 3, I want to know when this line actually crosses y equals negative 3. Okay, and this is not a perfect graph, but you can see I can quickly make a pretty accurate graph just sketching it out. Don't need graph paper or anything like that. Okay, so I'm going to make a quick table because I feel like that's the easiest way to get these on a graph. Now you might think you need to start with negative 3, but that's the y value. That's going to be this value right here. When do we get negative 3 over here? We're plugging in x. We want to know what's the x value. So let's say I plugged in 0 to start. Left to right here, 0 for x is here. So this will place this graph somewhere on here somewhere. So if I plug in 0, 5 times 0 is 0, minus 18, that's negative 18. So I'd have to go negative 18 spots. Now if you wanted to run your graph all the way down there, or count by 5s or something to fit the negative 18 on there, you could. But since I'm specifically going for y equals negative 3 up here somewhere, I'm just going to assume that I don't need this negative 18. 0, negative 18 is going to be down here somewhere. So let's see what happens. Let's go to 2. 5 times 2 is 10, minus 18. That's going to be negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I've got negative 8 on here. So if I go over to 2 on the x and negative 8, here I am. So I've got a point on my graph. Now if you remember, 0, negative 18 was down here somewhere, which means this line is going up this direction. So I can start to picture what my line is going to look like. It's going to go up like this. Now, starting to get better at examining these lines. If the coefficient is 5, for every 1 that I increase this, it's changing this by 5. So I'm already at negative 8, and I'm trying to get to negative 3. That means I better just go to my next number of 3, and that should get me there. So when I plug in 3, 5 times 3 is 15, minus 18 is negative 3. So 3, negative 3. 1, 2, 3, 1, 2, 3. There it is. Now it helps, you probably want to put one more point up here, so let's do 4. 5 times 4 is 20, minus 18 is 2, so 4, 2, 1, 2, 3, 4, 1, 2, just kind of helps you draw the line. Having 3 points helps. So the line looks like this. Now, if they told you to make a table like they did on 2 and 3 and circle the solution, when does y equal -3? It'd be right here, when x is 3. But they want you to show it on the graph. So this point is right here. Here's -3. When does y equal -3? So from -3 on the y-axis, you draw your dotted lines, and it hits right there. But what's the answer? What's the x value that created that? You're going to follow that straight up and show that it hits at 3. So just like circling this shows the solution, putting these dotted lines from y equals -3 to your line, and then up to the x value that created it, which is x equals 3. This is another way to show the solution, just on a graph. Just a different way to show it. Okay, after 5, we're going to go 7 to 9 now. So for 7 through 9, we're going to define the variable and then represent the relationship. So defining the variable means if you choose x or something like that, you're going to define it and say what it represents. So we're going to try and choose letters that make sense, but we're also going to define it by showing what it actually represents. So Solana lives where there's no sales tax. That's just showing you don't have to calculate any special percentages. So she buys 5 pieces of pizza for her friends with a $20 bill. So she starts with $20. She's going to spend money. So 20 minus something. So if we knew the price of a pizza, we would multiply it times 5 and take it off the 20. So it's going to look like this. $20 minus 5 pizzas, whatever the pizzas cost. If they were $1 each, 5 times 1 is 5. It would be 20 minus 5. She'd have $15 left. So she received $7.65 in change. So after she paid for these 5 pizzas, after that came off of her 20, she was left with, or it equals, $7.65. What's the price of one piece of pizza? So you could solve this to find that out. We don't have to do that. It didn't say solve for your variable. It just said define the variable and represent it with an equation. So we've already done the representing as an equation. $20 minus 5 times the price of a piece of pizza comes out to $7.65, where P equals, this is called defining your variable. What does the P actually represent? Don't just say pizza. It's the price of one slice of pizza. Be very specific with what your variable represents. Don't just say pizza in general. Okay, number 8. Trevor's riding his bike across the U.S. He started in a town on the East Coast. He's already biked 630. That's your starting point. He's going to add on to that. He's already rode 630. He's going to ride more. He's going to add how much? 82 per day. 82 times the number of days. In the end, we want to know how long is it going to take him, how many days, till all of this miles equals 3,210. So D represents the number of days. And we want to know how many days. So if it was 2 days, it'd be 2 times 82, because every single day he rides 82. How many days until he goes 3,210? So 82 per day, you're going to add that to the 630 that he's already ridden or rode, and then we're going to figure that out. So you could solve this equation, and we'll talk just in a second about solving equations. But for this problem, that's all you have to do. You didn't have to solve it. And then number 9, Coles are saving money they currently have, so they're starting with $5,275. They are saving more. They are adding to their savings. $950 every single year. I'm going to use Y for years. We want to know, when is this going to total up to? $20,000. So we don't have to solve this for the specific question, but this would get us there. You started with this much money. You're adding $950 for every single year. If it was 2 years, 3 years, 4 years, you would multiply $950 by that number. Add it all together. When does it come out to $20,000? So Y represents your number of years. If you just said years, that's fine. All right, after number 9, we jump to 14 and 15. And we're looking at these shapes, we're looking at perimeter, which right away tells me I'm adding up all of this. So for these problems, we're going to write an equation involving the variable. Okay, so perimeter equals, then use any method to find the value. So perimeter means adding them all up. So you could write it out, x plus 16 plus the other x plus 16. That's adding up all your sides. You also could have simplified early if you saw, okay, there's two x's, so I'm just going to write 2x. And 16 and 16 is 32, so I'm just going to write 32. That would be the same as combining like terms right now. It's 2x. 16 and 16 is 32. So the perimeter equals 2x plus 32. Now they told you the perimeter of the rectangle is 46. So all of this added up equals 46. We can change the value of p, the perimeter, to 46. And then solve it. Now we haven't gotten very specific on solving these two-step equations, but you should already have some knowledge of this from middle school, and we have dabbled in it. We haven't gone through explicitly what we're going to do, although the next section, that's what we're jumping into. But basically, something plus 32 is 46. So you want to figure what that is, you go backwards, you minus, and that's what we're doing here. One of our properties of equality says you can subtract the same number from both sides of the equal sign and maintain equality. So when you minus 32, you get 0. So we're left with 2x. And then 46 minus 32, that's 14. Now 14 equals 2 times some number. We know that's 7, right? So x equals 7. What did we actually do? To go backwards, you're dividing. 2 times something is 14. So 14 divided by 2 gets you the answer. Now, algebraically, why this works is because 2 divided by 2 is 1. So we end up with a 1x, which we just write as x. And 14 divided by 2 is 7. If the solving part is a little confusing, 3 should answer all your questions. We're going to dive deep into how do we do this every single time. But we need to be able to add up all the sides to get perimeter. So 15, we're going to do the same thing. 15 is this triangle. Now the perimeter is 97, so I'm going to start with that. 97, the perimeter equals all the sides added up. I'm going to simplify early here. I have a 3x, and a 2x. That's 8x. I'm adding up all the sides. Perimeter is the distance around. A -6, a -6, and a +1. So -6 and -6, -12, plus 1, that's -11. So there's my equation for the perimeter. Now I just need to solve it. So going through my steps, something minus 11 gave me 97. So I want to work backwards. I'm going to add 11 to 97 to figure out where I was. Now, -11 plus 11 is 0. So algebraically, I'm left with 8x. And then I'm going to add this, and that's 108. So 8 times something is 108. If you want to figure that out, you just work backwards and divide. 108 divided by 8. Algebraically, we are dividing by 8 on both sides. It looks like that. So 108 divided by 8 equals 13.5. So 108 divided by 8 is 13.5. Algebraically, 8 divided by 8 is a 1x, leaving me just x. And my answer is 13.5. Last question, number 19. So we've got these redwood trees. You can see the picture. They're known for just being absolutely massive. They're the world's tallest trees, growing an average of 3.5 feet every single year. If a tree already starts as 28 feet tall, its height represented by h after y years, so any number of years, can be described by this formula. So h equals 28, which is what the tree started as, and they told you it grows on average of 3.5 feet per year. So starting at 28, the height is going to be 3.5 more than 28, depending on how many years we're at. So letter A, make a table of values. So when you do that, we're just talking about this. So we're going to plug in numbers for y, which is the number of years, and see how tall this tree is after every single year. So if we start with 0, that's your starting point. It should be 28. So you plug in 0, cancels this out, and you're left with 28. After 1 year, 1 times anything is just itself. So it's grown 3.5 feet. 28 plus 3.5 is 31.5. It should go up by the coefficient to your variable. So 3.5 is what it's increasing by. So after 2 years, you plug in 2. 2 times 3.5 is 7. 28 plus 7 is 35. Notice it's gone up by 3.5. So this should go up by another 3.5, so that's 38.5. If you run the numbers, that'll happen. Plug in 3, multiply, add it to 28. That's what you get. So there's a table. That's letter A. Then they want you to draw a graph for letter B. Notice I've got all positive numbers, so I don't need to make a 4-quadrant graph. I'm just going to make a positive graph here. So my y values, now it can be a little confusing because we're using the letter y here. But when I talk about my y values here, that's actually the value of the expression. So it's these numbers. This represents time. Whenever you make a graph, you want time to go across the bottom. So it's 0 years, 1 year, 2 year, 3 year, 4 year, 5 year. These are the years. And then as time passes, we can see this thing grow or shrink or go up and down. So anything representing time, we usually want to put that across the bottom of our graph. So even though this is called y, that's our x value here. And the value of the expression, which is the y-axis, we got to get to 28, 35, things like that. So I'm going to count by, let's go by tens. 10, 20, 30, 40. And you can see I thought about that and I was trying to figure out what to do. I know if I went by tens, I'd get all the way up to 40. And my numbers are between 28 and 38, so they're going to fall in between here. So at 0, I'm at 28, which would be here. At 1, I'm at 31.5, a little bit above here. 2, I'm at 35, so right in the middle. And 3, I'm at 38.5, so almost to the 40. And this is consistent. It's going to grow exactly 3.5 according to this statistic every single year. So it's increasing at a steady rate. That's a line. And of course, it grows between 1 year and 2 years. It doesn't jump up on the 365th day. So we can connect this. Okay, the domain is not just integers. It's not just 1 and 2 and 3. It's everything in between because the tree is constantly growing even between the 1 year and the 2 year and the 3 year, right? It's going to grow all year long. So we can connect those dots. Letter C, how tall will the tree be in 21 years? This is when you go back. Years represents 21, so you're just going to plug it in. 3.5 times 21. So 3.5 times 21 is 73.5. Now that's not how tall it's going to be because it started as 28, so we have to add the 28. The 73.5 is how much it's grown. So we're going to add the 73.5 to the original 28, and that's 101.5. And this is feet. And letter D. How many years, so we're solving for the years now, will it take for the tree to grow to a height of 259? So if we go back to the original formula, we're going to have to solve for y. They gave us the height. So we're going to go ahead and plug in for h, not for y here. You're not plugging in 259 for the number of years. 259 is the number of feet. That's the height. So I plug into the equation 259 for h. We don't know the number of years, so we leave the y alone. And we have to solve this equation for y. So again, a little bit ahead of where we are, and 3.3 will really get into the nuts and bolts of how you solve these equations. But we want to isolate this variable, so I'm going to minus this 28 from both sides. Algebraically, that clears it out, gives me 0 on this side and leaves me just 3.5y. One step closer to having it just y. 259 minus 28 gets me 231 on the left side of the equation. This is 3.5 times y. So to reverse it, I need to divide. Anything divided by itself is 1, so algebraically I'm just left with y. And 231 divided by 3.5 gives me my final answer of 66. So after 66 years, the height will be 259.